you guys, welcome to week 5. We're more than halfway through the quarter. So lesson 13 is going to be about kind of a cumulative review of all of our exponent properties that we did over the last couple weeks. So we need one place to kind of put all these down in like a set of notes, all right? So I've got a head start here where I've kind of marked the base here and the exponent. Just wanted to talk about these words that, here we're calling them rules, and in some of the videos I think you're going to watch, they'll call them rules, but rules, laws, properties, all the same thing, okay? Okay, I started trying to write these out and it was a disaster, so I kind of went back and tried to type them. So the product rule is just that when we're multiplying, okay, when we multiply powers, those that have the same base, the rule is just to add the exponents. So this power has a base of x and this power has a base of x. Because it's the same base, I can just add these two exponents. Okay, so that's one example. Now it goes, just stands to reason if we're adding those exponents when we are multiplying powers, that quotient rule when we're dividing powers that have the same base, well, we would subtract those exponents, right? So I've got that example here. Remember that this is a division bar, right? So that's why the result is this quotient. Okay, third one down here, power to a power. So power to power looks like x to the third power. And then we raise it to a higher power, another exponent outside. And so the rule here is that we multiply this exponent inside by the exponent outside. And so that's x to the 12. The product to a power, product meaning we already have something that's being multiplied. So like x times y, that's a product. We've got two factors, x and y. If that whole thing is getting raised to a power, let's say 5, then all of these factors inside are getting raised to this 5. It's like a distributive property idea, and you might even want to write that down in your own notes, that we distribute that exponent to each part of the product, each factor inside. Okay, same thing's going to happen when we have a quotient where we're dividing something. Right? So this is a quotient, x divided by y. If that quotient is raised to the third power, the numerator and the denominator are both raised to that power. So it is distributive property kind of idea. Same thing here, we distribute this to both factors. We distribute it to numerator and denominator. The zero exponent rule just says anything to the 0 power is going to equal 1. So x to the 0 would equal 1. 9 to the 0, that's going to equal 1. Okay, and then our last one is a little complicated. It kind of has to do with reciprocals, where if we have a negative exponent, anytime we see that, that means it's not simplified. Okay, it's not writing very well here. Let me change angles. Not simplified. Okay, and it's a lot like simplified. Is that right? Simplified. That looks really weird. It's a lot like fractions, that we have to reduce them or they're not simplified. We have negative exponents. We say that those aren't simplified if they have any negatives in them. So if we have one that has a negative exponent, and right now it's in the numerator, we have this invisible 1 of a denominator. To make it positive, we move it down to the denominator. And the reverse would be true. Also, if it was already in the denominator and was negative, we would move it to the numerator, and then it becomes positive. You're going to want these notes for some of the practice that we're going to do. You're going to do kind of create your own notes with some cut and paste activities, and you're going to listen to some videos. And then tomorrow we're going to do a lot of combining this, which can be kind of difficult, so you do want to have these available, okay?